Hi, in this video we are gonna do a blockchain demo. We are going to use this website, which we have seen. Before I start, I want to thank Andrew Brownworth for making this website public so that everyone can utilize it. So what we have seen before is the SHA-256 algorithm. Since it is a cryptographic hash algorithm, it has some properties. For example, it is one way so that we can get our hash from our data, but we cannot get the data from our hash. It's just like the fingerprints of human beings. And the other property of SHA-256 algorithm is it is deterministic. Even though you change your environment, when you put the same data into SHA-256 algorithm, you will get the same hash regardless of time or place. Okay, for example, when you say hi, you get a hash value starts like 3639, and it will be same when you type hi in any environment with SHA-256 algorithm. But when you type it with like lower h, so it's gonna be something different because it's not the same data anywhere. Even you add a space, it's gonna change every time you add a space. So that's the whole idea about SHA-256 algorithm and how to understand it in block-wise. So let's go into block. So in this regard, we have something different here, which is our nonce value. We have mentioned nonce value before, but let us understand it visually. The first thing that we need to understand, there are a lot of miners and they all want to mine a block to get the block reward. So yes, there's a reward system. That's why miners are trying to mine the blocks so that they can get the reward. That's the whole idea. And they create very strong computers to make fast computations. But if there are a lot of miners, we also need to create an environment where finding a hash value is not that easy. And to be able to do that, we have a difficulty level. Difficulty level is basically the leading zeros here in our hash. In this example, it's 4 zeros, but it can be 10, 15, 20. It's gonna set the difficulty level of the system. And when there are more zeros, it means the hash value we want to get will be harder as well. For example, let's just type something, blockchain demo. So for this data, I need to get a hash value with 4 leading zeros for this system. But of course, if there are a lot of miners, this means, we should create that competitive environment and the system will increase the number of leading zeros so that it can be hard to find. So let's just mine it. Okay, it starts like 4 leading zeros, and in blockchain system will decide the number of leading zeros, as I said. So for example, let's give an example here. You flip a coin and you want it to be tails, 1 tails, right? So the probability of you'll get it is 50%. But when you flip a coin twice and want to get tails, you can just imagine instead of 1 0, you want 0 0. So now there are 4 possibilities. It can be heads, tails, tails, head, or tails. So now the probability that you will get the right result is 25%, not 50. So just like in our example, when you increase the number of zeros, it will be harder to find the right value. And one more time, system will decide this. For example, if mining a block is not that charming, the number of leading zeros will be decreased so that miners can come and mine the blocks because they do all the job. To be able to create a new block, we need to use some sort of energy, and miners do this by using their hardware, their computers. Okay, and of course you can also be miner and even find these values with your own computer. But if there is someone who has a better hardware system, they will do it in a short period of time and they will claim that, okay, I found the nonce value of this block. So this is related to what we have seen in our previous lectures. So I will just share my slide. Okay, here we have transaction pool, and we'll come to transaction logic in a sec on our website. But miners get some transactions from this transaction pool, and they are trying to find the valid nonce value with their hardware. When they found it, they claim that, okay, I found this, and they just broadcast to the system and they add the new block, their blockchain. And since they broadcast it, all the other miners can add the blockchain as well. For example, there are 2 miners trying to find the same nonce value with the signed hash. Then the one who has a better hardware system will get it first. And unfortunately, the other miner cannot claim that, okay, I also spent a lot of energy trying to find it. But no, that's not the case at all. Okay, this basically means if you have a good hardware system, system, you'll get the valid nonce value first. All right. So let us switch to our website again. Here, create another data. Let's say, what is going on? All right. So let's mine it. You see that it's taken more time. This means I will get bigger nonce value here because I still couldn't find it. You see that? It's like 414,000. So this means I spent more time because finding a hash value with 4 leading zeros took this amount of trial. And it is related to, your hardware, your computation pace. Okay, now we are done with hash and block. And in our next lecture, we'll continue with other parts as well.